Hello and welcome to video number 13A. Today we will look at several examples of all three types of swordfish: basic, finned, and sashimi. We'll do a quick review of how each one works to refresh your memory, and then we'll look at some related puzzles, okay? All right, here we go. In a basic swordfish, there will be three parallel rows or three parallel columns, each containing either two or three instances of a particular candidate. No less than two instances and no more than three. These are called the base sets, and these base sets must line up in such a way that three perpendicular houses intersect with them, covering all of the base candidates. These intersecting houses are called the cover sets. The cover sets can have any number of instances of the fish digit in them, as long as they cover all of the base candidates. In this diagram, the base sets are rows 2, 4, and 9 highlighted in green. And the cover sets are columns 3, 5, and 8 highlighted in light blue. Now there must be at least two base candidates in each cover set. Otherwise, it will be something else. It will either be an X-wing and a naked single, or simply a series of three naked singles, like this. Let's say this candidate in row 9, column 3 was not there, and there was only this one base candidate in column 3, which is one of the cover sets. So there's only one base candidate in column 3 now. What happens is that leaves an X-wing down here in rows 4 and 9 in the yellow squares, and that would eliminate this candidate 1 up in this base set, so this would become a naked single, and then there would be an X-wing. And that would eliminate all the ones in the blue cells in columns 5 and 8. And then if this candidate 1 was not here and left only this one candidate 1 in row 9, column 8, as the only base candidate in column 8, then that would leave a naked single here in row 4, and then you would have a naked single in row 2 and a naked single in row 9. So you must have at least two base candidates in the cover sets as well, okay? Now let's go back. Now because of this pattern, we know that exactly three of the base candidates will be the solutions to exactly three of the intersection cells, which are the yellow cells in this diagram, even though we don't know which. It could be like this, or it could be like this. It could be any number of ways. But we know that exactly three base candidates will be the solutions to exactly three of the intersection cells. Nevertheless, this means we can safely eliminate all instances of the fish digit from the cover sets that are not base candidates, i.e. that are not in the yellow intersection cells. So here you can eliminate all the candidate ones in all the light blue colored cells. That is how a swordfish works. Now here's a tip. Watch for conjugate pairs. It is extremely unlikely that there's going to be three instances of the fish digit in all three base sets, like this. If you recall from video 12, I mentioned that there are exactly 34 variations or configurations for a swordfish with regard to whether there are two or three base candidates in each base set. You know, like this is a possibility, like 2 and then 3 in the middle and then 2 down here. Or there could be 3 up at the top and then 2 here and all 3 at the bottom. Or there could be 2 in the bottom and 2 on the outside. And let's see, or it could be like that. It can be any combination. And out of those 34 variations, only one of them has three instances of the fish digit in all three of the base sets. This means there is a 97% chance, in other words, 33 out of 34, that any random swordfish is going to have two instances of the fish digit in at least one of the base sets. This means that at least one of the three base sets will almost always be a conjugate pair. And just for the record, there is a 79% chance that there will be two instances of the fish digit in at least two of the base sets, and there is an 18% chance that it will have two instances of the fish digit in all three of the base sets. So that's what you should look for. Whenever you see a conjugate pair in a row or a column, then look to see if you can find two other parallel houses to match up to form a swordfish. This will really help you find them. Okay, let's take a look at some real examples. All right, in this puzzle, let's take a look at candidate 6, and we'll light them up. Now let's do what I just suggested. Let's say you're looking at this puzzle at candidate 6, and you see in row 3 that there are two instances of candidate 6. There's your conjugate pair in row 3. So now you try to find some other rows that are going to match up with those. And we see down here in row 7, we've got a match on column 7, but these column 2 and 3 are missing. We need candidates in those columns, and here it is. In row 6, we've got a candidate 6 in column 2 and column 3. So there's your swordfish. There's your three base sets, row 3, 6, and 7. There are exactly two instances of candidate 6 in each of those rows, and they line up perfectly so that three columns can intersect with them and contain all of them. Column 2, column 3, and column 7. So that means we can eliminate all the other candidate 6s from those three columns. So that would be here, here, and here, and here. All of those candidate 6s will be false, and you can eliminate them because of the swordfish. Okay, next one. All right, in this puzzle, let's take a look at candidate 2, and let's look at row 1, row 6, and row 9. And you see you've got three instances of the candidate in two of the base sets, and only two in this middle base set here in row 6. So now there's your swordfish, there's your three base sets, so we can eliminate all other candidate 2s from those three columns that contain all the base candidates. So there's one here and here, and there's one here and here, and there's one here, here, and here. So that looks like there are 7 eliminations. You can eliminate that 2, that 2, that 2, that 2, and all three of those 2s in column 6. Okay? And with the swordfish, you can have up to 18 eliminations because there are 18 possible cells in those three columns that lie outside the intersection cells. Okay, next one. Okay, here let's take a look at candidate 7. And we've got a swordfish in the rows. Can you find it? Okay, once again, let's try what I suggested earlier. We've got a conjugate pair on candidate 7 in row 1, as you can see. Okay? And then we look down and we see we've got another conjugate pair in row 5. So now in column 8 we've got a match because there are two base candidates, but we need a second base candidate in column 5 and in column 7. If we look here in row 7, there it is. So now there's your swordfish. You've got the three base sets with two instances of candidate 7 in each set only, just two. And we've got three columns that go through all of those base candidates and cover them all. So that means we can eliminate all other candidate 7s from those three columns. So you can eliminate that one, and that one, and you can eliminate that one and that one. So there are 5. 1, 2, 3, 4, 5. Okay, let's go to the next one. Okay, in this puzzle, let's take a look at candidate 5, and we'll light them up. So we see in column 1, column 3, and column 9, we have a swordfish. And the cover sets here will be rows 2, 6, and 8. And as you can see, there are no candidate 5s to eliminate in this puzzle. That is what I call a dead swordfish when all the eliminations are already made. Now, sometimes you're going to find a swordfish where there's only one elimination, and sometimes there'll be none. And you can look at this either way. The base sets can either be the columns or the rows. It doesn't make any difference because it's a swordfish either way, but there is nothing you can do with it as a swordfish. Now, what's interesting in this puzzle is there is another fish pattern in here going on at the same time. But these two fish patterns do not intersect with each other, so they can exist independently. So the other pattern here is column 2, column 5 and 6, and column 8. Now that is a fish of size 4, which is the next step up from a swordfish, and this is called a jellyfish. Now this is a little bit advanced, and these are really hard to find, and we'll cover these later on. But as you can see, you've got 4 base sets and 4 cover sets with those blue cells. And there are no eliminations to be made on that one either. That is a dead jellyfish. And the swordfish and the jellyfish here exist independently of each other at the same time. So let's quickly take a look at some other examples of this in some other puzzles that I created. Here, for instance, we have 2 swordfish on candidate 9, and they exist independently of each other at the same time in this puzzle. The one in the yellow squares is in row 1, 4, and 7, and the one in the blue squares is in row 2, 6, and 9. As you can see, they do not intersect with each other at all. And you can also have a swordfish and an X-wing, which is also a fish pattern, existing at the same time, like this. The yellow squares are a swordfish, and the green squares are an X-wing, and they do not intersect with each other. And then you can also have 2 X-wings existing at the same time. On candidate 5, the yellow squares is one X-wing, and the green squares are another X-wing. And here it can also look like this. The yellow squares are an X-wing, and the green squares are another X-wing that exist independently of each other in the same puzzle. And all these patterns that I'm showing you right now, I call them dead because there are no eliminations to be made. But you will see configurations like this quite often when you're solving puzzles. Okay, let's go to the next one. All right, here let's take a look at candidate 5. And this time the base sets are going to be in the columns. And we've got column 1, column 5, and column 9. And so you see we've got 3 instances of candidate 5 in column 1, but only 2 in column 5 and 2 in column 9. But still there are at least 2 base candidates in each of the base sets, and they line up perfectly so that 3 cover sets can intersect with them and cover all base candidates. So because the base sets are in the columns, this time the eliminations will be in the rows. So we have one here, 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 and here. There are 5. So we can eliminate candidate 5 from all those red colored cells. Okay? All right, next one. All right, here let's take a look at candidate 1, and let's look in columns 1, column 6, and column 9. And as you can see, this is one of the rarest types of swordfish where there are 3 base candidates in each of the base sets. There are 3 instances of candidate 1 in column 1, column 6, and column 9. And this only happens 1 out of 34 times. That's about a 3% chance. But it does happen, so I'm glad this example came up. So now because the base sets are in the columns, and we have 3 rows that intersect with those columns and cover all the base candidates. And that is row 1, row 4, and row 6. So we can eliminate all the candidate 1s out of those 3 rows. And we got one here, 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 and we've got 2 in row 6. So there are 5 altogether, and you can eliminate all those candidate 1s. 1, 2, 3, 4, 5. Okay, and lastly, let's take a look at candidate 6 in columns 3, 4, and 9. There are your 3 base sets, those 3 columns, so we can eliminate all the candidate 6s out of the 3 rows that intersect with those yellow cells. So where are they? Well, Since the base sets are in the columns, the eliminations will be in the rows. So we've got one here, here, we've got one here, and we've got one here and here. There are 2 eliminations in each of those rows, so there are 6 altogether, and you can eliminate all those candidate 6s by virtue of the swordfish. Okay, I think that's pretty clear, so let's move on to the finned swordfish. If an otherwise perfect swordfish is spoiled by the presence of one or more fish digit candidates in one or 2 of the base sets, these extra candidates are called fins. When this happens, it is still possible to make candidate eliminations, but only according to the following 6 rules. The fin or fins must be contained entirely within only one block of the fish pattern. If there are fins in more than one block, the pattern is ruined. The fin or fins must lie only in the base sets, not the cover sets. There can be fins in 2 of the base sets, but only if those 2 base sets lie in the same chute. Candidate eliminations can only occur in the same block as the fins, and a candidate can only be eliminated if it sees all the fins. Okay, let's take a look at each one of these one at a time. And here we have a swordfish on candidate 1 where the base sets are rows 2, 4, and 9. And the candidate 1s in those yellow cells form the swordfish. As you can see, there are 2 fins in block 6. So rule number 1 says the fin or fins must be contained entirely within only one block of the fish pattern. So that would be block 6 here. Now rule number 2 says if there are fins in more than one block, the pattern is ruined. Like if there were another fin here or another fin here, this is not going to work. Okay? They can only be in one block. All right, so let's undo that. In rule number 3, the fin or fins must lie only in the base sets, not the cover sets. And as you can see, these 2 fins in row 4 lie in one of the base sets. If you have an extra candidate in one of the cover sets, it's not going to matter because that's where the eliminations are made. Rule number 4, there can be fins in 2 of the base sets, but only if those 2 base sets lie in the same chute. So like here, we have 2 base sets in row 5 and row 6. So you can have fins in both of those rows as long as they are all in the same block. And as you can see, they're all here in block 4. But that only allows one cell for an elimination in row 4, column 2. And the last 2 rules kind of go together. Candidate eliminations can only occur in the same block as the fins. And number 6, a candidate can only be eliminated if it sees all the fins. That's really 2 ways of saying the same thing. The candidate to be eliminated must see all the fins, so it has to be in the same house. And if they're all in the same block, then that qualifies. Okay, there's one more rare configuration that I want to talk about before we get to the examples, and that is when you have 2 base sets in one chute and 2 cover sets in another chute that are perpendicular to each other and that they intersect in one block like this. Here we have a swordfish on candidate 9 where the base sets are in columns 2, 3, and 9, and the cover sets are in rows 1, 2, and 7. And we can have fins in 2 of the base sets because they both lie in the same chute, and the fins are in row 3, column 2, and 3. And then you will also have 2 eliminations in the cover sets that lie in the same horizontal chute in row 1, column 1, and in row 2, column 1. Okay, that's not going to come up very often, but you might see that someday. All right, let's take a look at some real examples in some real puzzles. Okay, here let's take a look at candidate 3 in this puzzle. And we look down here in row 9 and we've got a conjugate pair. And then in row 4 we've got 3 candidates that line up with these 2 down here, but we need to match up one with this one in column 9, and there it is. And so that would be a swordfish, but you've got a fin here in row 2 in one of the base sets. So now you've got 2 cover sets and 1 chute. In the left-hand vertical chute, columns 2 and 3 are 2 of the cover sets. The other cover set would be column 9. So that means you can eliminate both of these candidate 3s in these 2 cells because they are both in the cover sets. So that is false and that is false. If that fin were not there, those 2 candidate 3s in the red cells would be false because of the swordfish. And if the candidate 3 in the blue cell were true, which is the only other possibility, those 2 same candidate 3s in the red cells would also be false. All right, next one. All right, let's take a look at candidate 6 in this puzzle. And in rows 6 and 7, looks like we've got something cooking. And we look up in row 2, and we match up our swordfish, but you've got 2 fins. So that spoils the swordfish, and you can make 1 elimination in column 3, which is one of the cover sets. So this candidate 6 will be false. Okay, next one. All right, here let's take a look at candidate 7, and this time the base sets will be in the columns. And column 2, column 3, and column 9. Now you've got 2 fins on either side of that base candidate, which means you can eliminate these 2 candidate 7s out of row 5 because the base sets are in the columns. So the eliminations will be in the rows, and either these 2 fins are both false, in which case these 2 7s in the red cells would be false because of the swordfish, and if either one of those 7s in the blue squares was true, those same 2 7s in the red cells would be false. So they're false either way, and you can eliminate both of them. All right, next one. All right, let's take a look at candidate 5. And remember what I said, look for the conjugate pairs. Here in row 3, you've got a conjugate pair. And then in row 4, you've got another conjugate pair, and at least 2 of them line up. So now you need another set of candidates that are going to match this one in column 2 and the one in column 9. And we look down in row 7, and we've got the 2 here and 1 over here, but then you've got a fin. So there's your swordfish, and there's a fin. So the base sets are in the rows, so the eliminations will be in the columns, and you can eliminate these 2 candidate 5s out of column 9 because they see the fin. You can eliminate that one and that one. Okay, next puzzle. All right, this one is kind of tricky. Let's look at candidate 8, and let's look in column 6, column 8, and column 9. Now there is a swordfish and you've got 2 fins. Now what's happening here is you've got 2 base sets. The base sets are in the columns. You've got 2 base sets in the same chute. So that allows you to have up to 4 fins, but there are only 2 here. But still, because the base sets are in the columns, the eliminations are in the rows, so you can make 1 candidate elimination here. In row 6, column 7, you can eliminate that 8 because that 8 would be false either way, whether the fins were both false or if one of them was true. Okay, and now the last one. Let's take a look at candidate 7, and we'll look at column 1 and column 9. There's a perfect match, so you should be able to spot that. And then here in column 5, you have to be really sharp to see that that would be a swordfish with 2 fins. And because the base sets are in the columns, the eliminations will be in the rows, and they have to be in the same block with the fins. So you can eliminate those 2 candidate 7s in row 5 out of column 4 and column 6. Okay, everybody got that? All right, these are kind of tricky, but you can find them with a little practice. So now let's move on to the sashimi version. As we learned in videos number 11 and number 13, it is still possible to employ the finned fish technique even if one of the candidates in the fish pattern is actually missing. When this happens, the fish is said to be degenerate, and it is called a sashimi fish. A sashimi fish will always have fins because without the fins, it will be something else. Here in this diagram, we have a basic swordfish on candidate 1 with the base sets in rows 2, 4, and 9. But let's say this candidate 1 here in row 2, column 5 is not there, and instead we have a 5 placed in there. Now without any fins, this candidate 1 here in row 2, column 3 becomes a naked single, which leaves a naked single in row 4 over here, and then a naked single in row 9. But now let's say we have fins here and here, one or the other or both. Now this is no longer a naked single in row 2, column 3, and we have to deal with this as a finned swordfish. So what happens here is if both of the fins are false, it becomes what I showed you a minute ago with the 3 naked singles. But if either one of those fins are true, then we have a swordfish, and we can eliminate these 2 candidate 1s from these 2 cells. Because if one of those fins is true, both those 1s in the red cells will be false. And if they are both false, then you have the naked single down here in row 9 as we showed before. You would have the 3 naked singles there, there, and there, and those 2 candidate 1s disappear in those red cells because they would have to be false. Now this also works whether that cell in row 2, column 5 has a digit placed in it or whether there are candidates in it. Let's say it looks like that. It works just the same. And the 6 rules for finned fish that we went over a little earlier also apply to sashimi, swordfish, or any size fish. Okay, let's take a look at some real examples. All right, here let's take a look at candidate 9, and we'll light them up. And we see in row 1, we've got a conjugate pair. And in row 6, we've got a conjugate pair, and they kind of match up. We got one match, but we need another candidate in column 1 and another one in column 8. So we've got the one in column 8, but the one in column 1 is missing. So this is a sashimi swordfish, and here are your 2 fins, those 2 9s. And that means we can eliminate candidate 9 in column 1 in these 2 cells. Those are both false. Okay, next one. All right, here let's look at candidate 2. And we see in row 2 we've got a conjugate pair, and in row 9 we've got a conjugate pair, and they match up. We just need another one in column 7 and another one in column 1. Now we've got the one here in column 7 here in row 5, but instead of having the last candidate over here in row 5, column 1, we've got a 3. Okay, so that makes this a fin, and because the base sets are in the rows, the eliminations will be in the columns, and in that same block with the fin, there is only one candidate 2 that we can eliminate, and that is right here. But let me show you a little trick. When you've got a sashimi swordfish like this, and in the block where the action is, so to speak, you've got one fin and one candidate to be eliminated, it turns out that the fin is going to be the solution for the fish digit in that block. Because if you make the elimination here in row 6, column 1, that leaves a naked single for candidate 2 in row 5, column 3. So instead of wasting time eliminating the 2 in the red cell, you can just go ahead and enter the 2 into the blue cell because it saves a step. This is what I call cutting to the chase, and you'll hear me use that term over and over again in all the tutorials. Cut to the chase. That's one of my favorite Sudoku expressions. And this comes into play whenever you can make one move that accomplishes the same thing as 2 or 3 other moves in one fell swoop. Now here in this diagram, as soon as you saw that the candidate 2 in the red cell was going to be false, you could have just as easily entered the 4 into that cell, like that. And that would leave the 2 as a naked single in the blue cell. That would be another way to cut to the chase in this example. But if those weren't 2 by value cells in block 4, then you could still immediately enter the 2 into the blue cell because of there being only one fin and one possible elimination in that block. And remember, this will only work with a sashimi swordfish and not with a regular finned swordfish. Okay, let's go to the next example. Okay, here let's take a look at candidate 8, and we see we've got a conjugate pair in column 1 and another conjugate pair in column 3. So there's the beginning of a swordfish, but we need to match up these two candidates in row 2 and in row 9, and we've got one here, but down here there is a 7 placed, which means these two candidates are fins, and we can eliminate the candidate 8 in row 9, column 5. Now, to remind you, the reason we can do that is if either one of the candidate 8s in the blue cells were true, this 8 in the red cell would be false. And if both of those fins in the blue cells were false, that would make this 8 up here in row 2 a naked single, which would negate this 8 in row 2, column 3, which would leave a naked single in row 6, column 3, which would negate this 8 in row 6, column 1, which would leave a naked single in row 9, column 1, which would negate the 8 in the red cell. I know that's a long explanation, but that's how it works. Okay, let's go to the next one. All right, here let's look at candidate 6, and this is a hard one to see. We'll look at row 2, row 3, and row 8. Okay, now you got a conjugate pair in row 8, but up here you've got two base sets in the same chute. So this 3 in row 3, column 8 is your sashimi cell, and that makes these 4 cells are all fins. And that leaves one candidate elimination in row 1, column 8, and you can eliminate that candidate 6. And because you've got two base sets in the same chute, that means you can have up to 4 fins and 1 elimination, just like that. Okay, next one. Okay, here let's take a look at candidate 5. And we see in column 8, we've got a conjugate pair. And then in column 3 and in column 2, we've got a sashimi swordfish. Now this one's a little tricky, but there are your 2 fins. And because you've got 2 base sets here in the same chute in column 2 and column 3, you could have up to 4 fins. There could be fins here too, but there aren't any there. There are no candidate 5s in those cells. But we've got 2 fins, which means we can eliminate the candidate 5 in row 8, column 1. And that will be false. Okay, and that's all you can do in this puzzle. All right, let's go to the last one. All right, let's take a look at candidate 8. And we see we've got a potential swordfish here in column 8 and column 6. There are 2 conjugate pairs that line up. And then what we need is another set of candidates to make a swordfish. We've got one here and here. There's your sashimi swordfish. Now, up here in row 1, we've got a cell where there's not a digit place, but there are candidates in there. And as I explained, that works just as well. So here's your fin. And because the base sets are in the columns, the eliminations will be in the rows, and so the only candidate we can eliminate here will be here in row 1, column 1. And you can eliminate that candidate 8. But here's another one of those situations where I said if you've got 1 fin and 1 elimination in the same block, you can just immediately enter that fish digit into the blue cell because the fin will be the solution. I know a lot of you probably think this is too many examples, but believe me, if you want to be a Sudoku master, you cannot look at enough examples. All right, so that's it for today. Let's go back outside and finish up. Thanks for watching. Well, I hope you have mastered all types of X-wings and swordfish now, because we won't be talking about fish patterns again for quite a while. In the next video, video number 14, we will start learning about simple chains. The first type of chain we will look at is oddly called a turbo fish, even though it is not really a fish by definition. And I want to remind you to please watch videos number 3 and number 4 and their adjunct videos in their entirety, and make sure you understand the very important concepts put forth in those tutorials before watching videos number 14, 15, and 16. That will make learning about chains much easier for you. Trust me on this. Okay, that's it for today. As always, thanks for watching, and I'll see you next time. Until then, be well and be happy.